Hi, and welcome back. In this video, I am going to teach you the LimboAI state machine for Godot 4.3. This is officially the second video in the series, in the tutorial series. In the first video, this one, we created a project, we installed LimboAI, we also added a platform with a texture and a player character with a sprite texture. If you already know how to do all those things and you got your own project and your own art, feel free to skip the first video. If you want some help, go and watch the first one first. I will wait here. Welcome back. Amazing, you are now ready to learn everything about the LimboAI state machine for Godot 4.3. Let's go. Before we start though, it's still the same recording as the previous video, so I'm still pronouncing variable as variable. I guess you just have to deal with it. I'm sorry. Let's go. All right, let's add the state machine to the player scene. Make sure to have the player scene opened. Yet again, click on the root node player and then add child node. Search for Limbo and then click on the Limbo HSM, which means a event-based hierarchical state machine, HSM. Double click and now you've added the state machine to your player. And while we are here, we can also add the states to it. Press right mouse button on the Limbo HSM and then search for the Limbo state. And then you simply press create. In this tutorial, we are going to create 7 states. So I'm going to duplicate it real quick. And let's also rename them while we're at it. One's called idle. The other one is called move, jump, fall, attack, air, attack, and crouch. Nothing of this is actually working right now because neither of these states have code attached to it. Also, the player code has no idea about the state machine in the visual editor, but we're gonna fix that in just a minute. Let's start with the idle animation. For that to make sense, we need to animate the sprite first. We do that by right mouse clicking on the player node. Yet again, press add and search for the animation player. It's this one. Double click. There you go. I prefer to have the animation player at the very tippity top. You can put it wherever you want, doesn't really matter. We have the animation right over here, and let's start with animating the idle animation. Make sure to have the animation player selected, and then there is this animation button. Click, select new, call it idle, and then we're gonna animate the sprite. You might want to watch a animation player tutorial first, but then again, it's pretty straightforward. So just do what I do and you're fine. In this case, the idle animation has a loop of 1 second, which sounds about right. Since I know that the idle animation has 8 frames, you can put 0.125 here, because therefore you can put all 8 frames into 1 second. I'm a genius at math. Click on the sprite here in the scene and then go to the properties yet again and open up the animations tab right over here. And when you're here, just click on this little key icon at the frame coordinates and just keep on pressing it until all 8 frames are there. Again, if you're completely new, this might be a bit confusing, but we are actually at the first row. 0 represents the first row of the sprite sheet. And this is X1, X2, X3, X4, X5, and so on. Make sure to put the animation on a loop by clicking on this icon. Now it's looping. You can test it. Yeah, it's perfect. So with the animation all set up, we're going to go to the player script. You can just click on this icon over here, and that will open the previously created script of the player. And again, this code has been generated previously whenever we checked the use the movement template earlier on. We're going to get rid of most of it, but let's just start with having a declaration of the state machine right on top. Go to the third line, add a nice little comment right over here that says state machine, and we're going to make a export var state underscore machine with the type of this node right over here. You are probably familiar with those export vars, but the thing that you can do now is clicking on the node, the player node right over here, And now you can use the inspector to assign a state machine to your code. So because we added this little line right over here, we can simply drag and drop the state machine. And by doing that, this variable points directly to this state machine object. Another thing that we can do is set some references to the states. So let's just put a comment here called states. And this one we are going to do somewhat differently. We're going to put a onReady var. We call it idle state. And we're just going to drag and drop this object right over here. And you can set those states in many ways. You can do some loop. You can probably also do it with export vars, but in this case, we're just going to drag and drop those every time we create a state. And the next thing that we want to do is to initialize the state machine every time the game starts, or at least the player object gets created. And we do that by creating a ready function. I think you guys all know that one. It's simply a function underscore ready. This is like this one-time function that only gets fired whenever the player scene gets created. And within this ready function, we're going to call another internal function called initialize state machine. Here you go. This function doesn't exist yet, therefore we get this error. So we're just going to put another function below it that initializes the state machine. There are a few things that you need to do. First, we're going to set the default state. So we're going to call the state machine, and I think it's called initial state. And we're going to put the idle state in there because that's the state that we want to start with. And therefore, the state machine knows that the initial state is the idle state. After that, we are going to initialize the state machine by simply saying initialize, and I think you have to put self there. And after that, you also need to activate the state machine by simply calling the setActive to true. And now there's only one step left, and that's to add some logic to the idle state. And to add logic to the idle state, you simply press right mouse button on the idle state node and say attach script. We're going to call this one idle, and it's perfectly fine. The only thing that I want to change is that I want to put it in the right folder. So I go to the root yet again, go to scripts, I go to agents, player, and I prefer to have a separate folder here called states. And within that, we are going to save the idle state. And as you can see now, the idle state has a script next to the node, which is very handy. I really like the visual way of editing in Godot. So every time when I want to change the idle state, I can simply go to the scene, press this little icon, and then the script will appear automatically. At line number 3, we're going to add 2 different script lines. One is called export var animation player with the type animation player. And the other one is an export var that holds the string name to the animation. If you save this file and you have the idle node selected, you will see in the inspector that you can once again assign an animation player. So let's do that. Click on it. And you can also put an animation name right over here. And if I remember correctly, we just called it idle with a uppercase at the front. When you do some research by holding Control and clicking on the limbo state, you will find that there are a bunch of methods that you can call. Don't you worry, you don't have to read it during this tutorial, but just know that there is a documentation that shows all the ins and outs of how the state machine works. In this case, we're going back to the idle state, this function right here, and we're going to add a enter function. I copy paste it from my notes, but it's simply a function underscore enter. It returns nothing, and it plays the animation that we set earlier. So it simply is referring to the animation player. It says play, and then it plays the animation that has been set here in the expector. One thing to understand, which is very important, is that the enter function right over here only runs once the state has been activated. So for example, when your character is running and transitions back to idle, the animation player only sets the animation one time. And if I prepared this tutorial right, I'm pretty sure that the idle animation is working perfectly. Yes, it is. We can still move in this case, and that's because the move functionality still lives in the player code. So by clicking on the little icon right over here, we go back to the player code. Also, know that you can also change here between the different files. So in the player.gd, there's now this jump functionality, the idle and movement functionality. You can delete that for now. Be careful not to delete move and slide, otherwise the character won't move at all in the future. So now we have a very bare bone small player code file with a ready that initializes the state machine, a physics process that only adds the gravity to the character, and it can potentially move in the future. But apart from that, it does exactly what we want it to do, and that's in being in an idle state. So congratulations, your first state, the idle state, is a success. All right, the next chapter in this tutorial, the transitions. This is where it gets interesting because we want to transition from idle to, for example, the move state. So yeah, let's start with the move state right now. Since this is pretty much like the base code for any states, I suggest we are going to make duplicates of all the states right over here that belong to the states that we set up. So let's go here and just press duplicate and call this one move. We're going to duplicate it again for jump and so on. So we created all the duplicates right over here. And now we're going to drag and drop the different code files to the state machine that it belongs to. So click on move, drag and drop move to script. Do the same for jump. And we're going to do the same for crouch. And since we are doing all this preparation, let's go to the player code as well, right over here. And then we are going to set all these states here as well. So we're going to add 7 more of them. Make sure to rename them. Move state, jump state, fall state, attack state. Oh, and as you can see, all these states here has been set with the same node. So let's delete that real quick. I could have done this a bit more optimal, but you get what I'm doing here, right? I'm going to set all the variables to the right node. So in summary, we have all these variables that are pointing towards these nodes that have their own classes, their own script files. So let's set up the transitions. Define state transitions, and also put a little comment below the setup state machine code. Great. To define transitions, you simply type out state machines, add transitions. The first one should be the from state. So we're going to say from idle state, comma, you can go to move state. And you go to the move state whenever the state machine is dispatching a to move signal. This will become a bit more clear in just a bit, don't you worry. But just know that whenever the state machine is active, and the state machine is also dispatching the to move signal, it will go to the move state. That's all what this code of line actually says. The next thing that we're going to do is that based on the movement, the keyboard movement or the controller movement, we're going to dispatch this move signal. In this tutorial, I'm going to set up a very basic movement system, something that's not very optimal, but I just want to keep this as simple as possible for the sake of this tutorial. Go right above the onReady function, and here we're going to set a movement input variable, movement input. It's going to be a vector2, and that basically means that we're going to store 2 values. And by default, it's going to be a 0, so no input whatsoever. Then we go to the physics process function, way at the bottom of your code file. Currently, we're only dealing with gravity and the default move and slide, but right here in between, we are going to set the movement input to this variable. The autocomplete will find the variable, amazing. And we're going to set this by putting input here, get vector. And we are going to listen to our left controls, right controls, up controls, and down controls. Amazing. So in summary, this variable right over here will get set based on your left, right, up, and down controls. This doesn't really work from the get-go because we have to define those left, right, up, and down controls from the input. And we do that by going to Project Settings, go to Input Map. And when you're at Input Map, we're going to define those left, right, up, and down controls. So left, right, up, down. And by clicking on this plus, you can add different controls to it. In our case, I'm going to say left is A, but left is also the left button on the keyboard. Right is D, but right is also the right button. Up is W, and also the up button. And down is S, and also the down button. So now we define left, right, up, and down. And if you want to print this variable and you test your game, of course, I'm in the way of the output. What's the optimal way to position myself? Maybe here. Let's try here. So as you can see, the vector gets printed out here constantly. Whenever I press left, it says -1 in the first part of the vector. If I press right, it says 1. And if I do nothing, it says 0. The same goes for the vertical movement system. When I press up, it says -1. When I press nothing, it says 0. And when I press down, it says 1. So now we can track our basic movement. The next thing that we're going to do is to make it so that the idle state keeps track of this movement input. And whenever there's input, while being in idle, it will dispatch the toMove signal. So let's go to the code of the idle state by simply clicking on the icon next to idle. So in the idle script, we have the enter function that only gets called once, but now we want to check the movement var of the agent every single frame. You would think that you want to add that in the process one, but that's not the case. There's a state machine function that we need for exactly that. That is called update. It also uses delta. It returns nothing. The big difference between the update and the process is that the process is being called in every frame of the game, and this one is only being called whenever the state is active. If you put the functionality here, then your whole state machine would break. I don't even think we need the process, so you can also delete it. We are going to check whether the agent's movement variable that we just created, the movement input, doesn't equal 0. In other words, if the movement input is 0, then the character must be moving, and therefore we're going to dispatch that signal that we are listening to called toMove. And you can do that by just calling the root of this state. And you can use getRoot because all these nodes are a child of the state machine. And the signal needs to be dispatched from the state machine. So you can put getRoot here and then say dispatch. And then you can put the toMove signal right over here. And that's it. You created your first transition from the idle state to the move state. The only problem is that we haven't set up the animation yet for the move animation. So let's fix that real quick. Click on the move node in the state machine. Tell it to play the move animation. Also, don't forget to assign the animation player of the agent. And by clicking on the animation player, we are going to add the move animation as well. Click on animation, select new, call it move. And again, if you're kind of new to the animation player, I suggest following a few tutorials, but I will just add the animation real quick here so this doesn't become an hour-long video. And there you go. If I put it on a loop, we got ourselves an animation. And now if we play the game, it will probably work. Yes, it works. It's kind of moonwalking right now, so let's try and add some movement to the movement code. Go to the move node, select the script, and to handle the movement of the agent, we're going to call a function in the agent's code that is called apply movement. It also needs a delta. This function doesn't exist just yet, but we're about to change that. Let's go to the agent's code and let's add a code right above the physics process that is called apply movement. It also needs delta. And in this function, I'm going to copy and paste these code lines from my notes. It's a pretty simple code, a pretty simple movement code for the sake of this tutorial. But what we are basically doing is that we are changing the velocity of the agent based on the X and Y input, and we multiply it by speed. The speed constant was already defined earlier whenever we created the automatic movement code from Godot. So we can just move this one, and you can change that if you want. But this is the move speed that was already declared. And here we are just applying it to the velocity based on the input. And now your game should work somewhat-ish. Yes, the character keeps on moving because the move state never signals a to idle state. So let's fix that real quick. So let's go to the move code once again. And from this moment on, I will be copy and pasting some code directly from my notes. But just pause the video every now and then if you want to take a closer look. But here, just below the movement check, we are going to check whether there is no input. It's quite similar to what we did in the idle update function. So whenever there is no movement, we are going to dispatch to idle. This doesn't work yet because we haven't defined the transition yet. So we go back to the player's code right over here. We go to the section where we defined the state machine transitions. And here we are going to add another transition. It's whenever we are in the move state, then you can go to the idle state whenever this signal has been dispatched. And with that, you just created another transition from idle to move and from move to idle. Let's check it out. Isn't game development cool? It's so cool! And as you can see, the character can actually moonwalk. But we don't want that. It's not MJ. We're gonna make this directional flip thingy. So let's go to the move script once again, and we'll be calling a function in the agent's code that's called something along the lines of update sprite direction. Yeah, this should be fine. This one doesn't exist, so we go back to the player's code and right above the movement. And here I'm just going to paste the code from my notes. It's the function that we just called. And based on the X movement input, we are going to flip the sprite. It currently gives an error because I haven't defined the sprite yet. Let's change that real quick. We're going to add another onReady var called sprite from the type of sprite 3D. And I'm going to just drag and drop the object in my code. And now if we play the game, it's actually is going to start like a game. Isn't that wonderful? So now I'm back in the player's code where we are defining the state transitions, and we're going to add the jump transition. We could just copy and paste both existing code lines and just change them both to jump state, just like this. So idle can go to jump and move can go to jump whenever it hears the to jump signal. There's also another way to do this by just saying that any state in the state machine can go to jump whenever it hears to jump, by just saying any state. And because of that, I can remove this one. So whenever any active state hears the to jump signal, it goes to jump. And in this case, it might not be too optimal and performance efficient, because maybe you want to control which state can go to the other, but I just wanted you to know that there are different ways to go about your state transitions. And to handle the jumping, we're going to add a function called check jump input in the player.gd's code. This function basically checks whether the jump input has been pressed, but later on in your game development, you can also check different variables. Maybe you want to restrict your character to jump, even though jump has been pressed, due to some cool gameplay idea that you have. And we can now easily copy this function and, for example, go to the idle script and just put the function right over here in the update of the idle. And then it obviously doesn't work because this method lives in the agents class. So now we are calling the check jump input in every frame of the idle state. And we are going to do the same thing in the moves code. So now in the idle and also the move update function, we are constantly checking the jump input. One thing that I forgot is to configure the jump. So let's go back to project settings, go to input map and add the jump input. And here you can, for example, just add spacebar or any other key that you prefer. And that's it. We successfully added a jump transition from idle and move. The only thing that we have to do is to actually set up the jump state. So click on the node jump right over here, add the animation string and also the animation player. I'm adding a jump animation. And that's the jump animation. And now when we test the game, the character jumps. It doesn't actually jump yet, it only shows the animation. So let's change that too. Let's go to the jump code right over here. And in the enter function here, we're going to add the following code. Pause the video if you want to copy and paste it real quick, but we are basically telling the velocity of the agent that it needs to jump with a specific amount of jump velocity. This constant right over here was already defined by the default code of Godot. Because if we go to the code, the player code right over here, it already says right over here that it has a jump velocity of 4.5. And this is why the enter function is so handy, because this is only being called once, so you can literally push your character one time. Otherwise it will just fly indefinitely. You don't want that. And with that, the character jumps. It doesn't land yet, it also doesn't fall, but we're about to fix that. So we go back to the player scene, we click on animation player, we're going to add a fall animation, and you know the drill by now. And now you have this little fall animation. And within the jump code, we're going to check in every frame of the state, and I have to change this to update again, because we don't want to use process. Please remember that, otherwise everything will break. But within the update function of the jump state, we're going to add this little code. And this reads as follows. Whenever the Y velocity is below 0, whenever the character is falling, and the agent is not on the floor, then dispatch the to-fall transition. Let's go to the player's code and go to the transitions yet again. And for the sake of simplicity, I'm going to abuse the any state yet again. So if any state hears the to fall signal, go to the fall state. Make sure to set the animation and assign the animation player. And now we should have a fall animation too. Great. Amazing, that looks so cool. And to make it so that you can land during a fall state, we are going to do the same thing. We're going to change this to update. And right over here, we are going to add the following code. It's pretty straightforward. Whenever the character is on the floor and there is no movement input, go to idle. Whenever your character is on the floor and there is movement input, go to the move state. The only problem now is that only the idle state and the move state are listening to the to move and to idle. We're going to copy and paste the any state exploit real quick, just for the sake of this tutorial. Obviously, in your own game, you want to be very strict to what state can go to another state and the other way around. But for the sake of simplicity, I'm just going to let any state listen to those signals. And now if you press play, it works. And you can also instantly walk after touching the floor. And I realized that when you jump, you really have to commit to the jump because there's no movement input while jumping currently. But that's the beauty of state machines. I can easily go to any state that has the apply movement function in the update. And now I can just simply copy paste this and also put it in jump and also put it in fall. And now you can also move while jumping and while falling. And this is actually by accident a good example why state machines work so well. You've got so much control. And again, applying movement in the update function of any state is probably not best practice, but for the sake of this video, it works and you get the picture of how state machines work. In my own game, I created a movement controller, a different component, but that's something for a different video. All right, that's it for the basics of the state machine. I'm going to take a break. If you want, you can close this video or just stay with me for a while, and I will also show you how to implement the attack, air attack, and crouch. All right, see you in a bit. I'm back. Let's do the remaining states, the attack state, the air attack, and crouch. Let's start with crouch. Let's go to the initialize state machine function in the player code. And here we're going to say that whenever you are in the idle state, right over here, you are able to go to the crouch state. And we're going to listen to the signal that says to crouch. When you've got the crouch node selected, make sure that you put the right animation name right over here and also assign the animation player. And here we're going to add the animation crouch. We say new crouch. And now we've got our crouching animation. And now I go back to the player's code, and just like the jumping function check jump input, we can also add a check crouch input. And whenever the action crouch is being pressed, then you're going to dispatch to crouch. And just like the other events, this only works whenever you've got it configured. So let's go to project settings. We add crouch right over here. And in our case, I think I'm gonna put it on C. I wanna make it so that you can only crouch whenever you are in the idle state. So I'm going to the idle state, and here in the update, I'm gonna say agent and then check crouch input. And I feel like that's it for the crouch animation. I feel like we are forgetting something. Let's check if it already works. Yes. It already works. Amazing. Yeah, that's the thing with the state machine. Whenever you get the hang of it, expanding your code goes pretty fast. Currently, you cannot get out of this state because there's no transition from crouch to idle again. So let's fix that. And we can do that by going to the crouch state. We're going to change this to update once again. And then we're going to put this code right over here. If the input of crouch has just been released, please go to idle. And I think if we check it out right now, here we go. You know, you could also add a crouch out animation, so it does this animation in reverse. But that's something that you can figure out yourself once you kind of understand the basic of a state machine. All right, let's get violent. Let's go and fix the attack. First, we're going to assign the animation player for this state. We will call it attack. You know, and while we're at it, we're also going to set up this one, air attack and animation player. So, all right, cool. First, the normal attack. Let's go and fix the animation. I'll select animation player, new attack. Game development is so much more fun when the art style and the sprites are pretty. Just look at that. It's so gorgeous. And you know what? Let's make the air attack as well. You know, the animation is slightly different. The air attack has the feet like hovering in the air. So with these all set up, both the references and the animation strings and also the animations, it's all about coding next. So yeah, let's go and do that. Let's go to the player code once again and add the transition. Let's go and define the states, shall we? And in this case, I only want you to be able to attack when you are in idle. So we can just put it like this. Attack state from idle, and we call it to attack. And while we are at it, we're also gonna put the to air attack here. And now we have to make sure those signals get dispatched whenever you press attack. Yes, in my own game, I would probably have like separate attack and movement components. For the sake of simplicity, we're just gonna put a function here that's called check attack input. And here we are going to, let me see, we're gonna check whether the character is on the floor. Whenever you are on the floor and the input attack has been pressed, then we're going to dispatch the normal attack to attack. I can also do a elif right over here. If you are not on the floor and you press attack, I am going to say to air attack. Right, this should probably be it. I'm pretty sure this is it. Now, with this function, I can just add it to, in this case, the idle state. So agent.check attack input. And I also want it to be in the jump, not the fall, because I feel like you should not be able to attack when you're falling. It's my game, all right? I get to decide it. Let's see if it works. I don't know. I don't think I have an attack button yet, right? Yeah, I think I forgot that. Yeah, we don't have attack at all. So attack, let's put it at control for the sake of this tutorial. Amazing. So we also now defined attack. Let's do it again. Yes! And let me restart real quick. And the aerial doesn't work yet. Oh yeah, so I only set the transition here from idle to air attack, and this should be jump. So because I didn't define the transition, it could no longer, it could never, to begin with, go from jump to air attack. So now it should work. Just a sloppy copy-paste problem. Amazing. Yeah, so the only problem now is that the animations, they never really reset. And to fix that, you go to the player scene, you click on the animation player, then you go to node, and then you should look for the animation finished signal right over here. And you can connect this to a script file. In our case, we're going to connect it to the player script. So I think it's already, yeah, it already has the node selected. And now we can just press connect. And now in our player code, there's this function called on animation player animation finished. And every time an animation is finished, it will run this function. And we can also check this animation right over here. And right over here, you can say if animation name equals attack, then state machine dispatch to idle. Oh, we need a column here. We can copy this and also say if it equals to air attack. For now, just go to fall, I suppose. This might already work. Yep. Amazing. And that's it. You've mastered the LimboAI state machine. But don't go away just yet. I still got a few tips and tricks and directions for you before you leave. Yeah, this video pretty much covers the basics of a state machine and pretty well, if I say so myself. But it's not like optimal code, the way I implement all the other things, such as the movement and the way how I go about input. There are way more ways to be flexible with the state machine. You can have all this code in separate components to make it more efficient and less buggy. And a good way to learn more about those best practice or better practices is to go into the demo folder. For example, if you go to agents, player, and then player.gd, you will see that they had a different approach regarding the transitions. There's also a way to listen to event finished instead of always listening to your manual signals. And apart from that, it kind of looks the same. But my point is that whenever you master the basics, there are so many creative ways to implement the state machine. There's no one right answer here. For example, in our code, we connected the animation player to this animation finished function. It works fine, but I feel like there's a better way to just directly listen to certain animation being finished and therefore sending it to a different state. I'm pretty sure there's a better solution for that. But you know, you will learn that eventually. I will learn it eventually, but this is pretty much the basic implementation of a state machine. All right, that's it. I really hope you enjoyed this tutorial. I hope it was helpful to you. My next video will be about the behavior tree. It's a behavior tree also provided by LimboAI. And I honestly feel like the behavior tree is like the coolest thing in game development. You are basically creating little creatures, entities with their own mind and their own decision making. So keep an eye out for that video. Hopefully I'm going to upload it in January as well. There's still 15 days. Well, we'll see. Please give the video a like, subscribe. It really helps a lot for the channel so I can reach as many people as possible. And with that being said, bye-bye.